When you're dealing with simple fraction problems in math, the thing you're interested in is the denominator. So in other words, if I have 1/2 plus 1/2, if the number on the bottom, the denominator, is the same, you can go ahead and just add the two top numbers together. In this case, 1 plus 1 is 2, and then keep that same number in the denominator. So in this case, if you have 1/2 and you add another half to it, you get a whole. That makes sense because this 2 over 2 is the same thing as 1, because what we're really saying is 2 divided by 2 is 1. You could have a slightly different problem, 2/3 plus 2/3. And it's supposed to be a plus sign. And so you've got a common denominator, so you just add the two top numbers together. 2 plus 2 is 4. Keep the same number in the denominator. And now this is what we call an improper fraction because the top number is larger than the bottom. And this can be reduced or simplified. So we ask ourselves, okay, can 4 be divided by 3? Sure can. 3 will go in 4 one time with 1 left over. And then again, I keep that same number in the bottom. Notice how that 3 is appearing in the denominator all the way through. That's the common denominator. And this works for subtraction problems as well. If I have 5/8 minus 3/8, so the denominator is common, I can just start my problem off by writing it again in the denominator of the answer. And then 5 minus 3 is 2. Now this fraction can be simplified because I can divide the top and the bottom number by 2. So if I do that, on the top, 2 divided by 2 is 1, and 2 divided by 8 is 4. So there's the simplest form of this answer, 1/4. Now the trick comes when you're trying to add two fractions together and you do not have the same number on the bottom of each one. So that would be like 1/2 plus 1/3. You cannot add these right away. You've got to find a common denominator for these two fractions. So I'm going to show you a technique. It's called the cross multiplication technique. What we do is we multiply the two bottom numbers together. In this case, 2 times 3 is 6, and I'm going to write that 6 on the bottom of both these new fractions over here. And then we cross multiply like this. 2 times 1 is 2. 3 times 1 is 3. Now, since we have a common denominator, we can just add the two top numbers together. 3 plus 2 is 5 over 6, and we get the answer. The same thing works for subtraction. If we have 5/8 minus 1/3, we can't do this subtraction problem right away. We have to find a common denominator. So we're going to multiply the two denominators together. And oops, I don't want a plus sign, I want a minus sign. Minus, I'm preparing my two new fractions here. Okay, so 8 times 3 is 24. I'll write 24 on both denominators. And then I'm going to cross multiply. 8 times 1 is 8. 3 times 5 is 15. Now I can just subtract the two top numbers, and I'm going to keep the bottom number of the denominator the same or common. 15 minus 8 is 7. So one final thing to show you, or let's try a little more difficult problem. How about 7/9 plus 5/8? So again, I can't add these two fractions together directly. I've got to find a common denominator, and I'm going to use my cross multiplication to do that. 9 times 8 is 72. So 72 is our new denominator. And then I'm going to cross multiply. 9 times 5 is 45. 8 times 7 is 56. Okay, now I can just simply add these together. So 56 plus 45. Well, I could do it in my head, but I'd better take the time to do this longhand so I don't make a mistake. 56 plus 45. 6 plus 5 is 11. Carry the 1. 1 plus 5 is 6. Plus 4 is 10. So the answer is 101. So what I'm going to do is put my 101 over 72. Now notice that this is an improper fraction. Most of the time you'll be asked to simplify this answer, and we know it can be simplified because this is really like a division problem. 101 divided by 72, and we ask ourselves, hey, will 72 go into 101? Well, we can see that it'll at least go one time. So let me come down here and start on a new row. So we know it will go one time. And then how many is left over? Once we divide 72 into 101 one time, that's going to leave a remainder of, well, I can't do it in my head, so let me go ahead and just do this subtraction problem here. And so I have 1 minus 2. I have to borrow. I can't borrow from 0, so let me borrow 1 from this digit, and I'm going to write a 10 here. And now I've got 10 here. Let me cross this out. This is going to become a 9 because I just borrowed 1. And then here's the one that I finally borrowed over here. So it's 11 minus 2 is 9. And 9 minus 7 is 2, so 29. So that's the remainder. Once I divided 72 into my 101, I got 1 and 29 was left over from that, over 72. And again, notice how this common denominator stays with us even to the final answer. And this can't be reduced, it doesn't look like, so this would be your final answer.